Hypothesis testing can feel pretty complicated, but we've really covered all the theory you need to know to understand this concept. In this video, I'm really just going to show you an overview of the process and the concepts, and in later videos, I'll get into each of these steps separately. If you want to see the whole process together, I encourage you to go straight to 9.5 and look at these two situations. We have a quantitative test about the population mean. The basic steps are make a statement regarding the nature of the population. So something like the population mean has changed from its value before, or it's above or below a certain value. Next, we check the requirements and we look at the level of significance. Step 3, we measure the sample against the claim using technology. Step 4 is to make a decision, and that decision is very quick and easy if we've got all of our information clearly stated. And then lastly, step 5, state a final conclusion. So I think of it as setup, requirements, measure the sample against the claim, make a decision, and state your conclusion. Now let me take you through this. Take a step back from all these symbols and all this theory and look at what this all means. So go back to the concept of sampling distributions. Let's say we take a sample of 50 voters. We presume that the winning candidate won with over 50% of the vote. In our sample of 50 voters, then, we have a standard error of 0.071. So that's p times 1 minus p over m. So what we're doing is we're assuming that the middle of the distribution is 0.5, even though really it should be above that. And now if our sample is far enough above that, we've exceeded a margin of error. So kind of imagine what a confidence interval would look like on this distribution. For example, if I wanted a confidence interval of 95%, I would just need to shade the central area of 0.95. Now take note of where that line is drawn. That means this right area is about 2.5%. So I can also shade the right tail of 0.025. I get that same z value, and now just the right side. So that would sort of tell me where my margin of error ends on the right side. I would want a sample to be sufficiently beyond that margin of error to show that it's not just sampling error. More likely than not, we actually have a middle of the distribution that's above 50%. So looking at samples, I'd want to calculate the area under the curve and just look at, for example, a sample where 63% of the vote was for the winning candidate. I see that the likelihood of that, or more extreme, is 3.36%. So I would think that that would be beyond reasonable doubt. It's not impossible to land past there, and it's definitely going to happen sometimes, but we're not going to be able to make this decision right every single time. So what we could say here is that a sample of 53, and with a sample of 50 voters, I actually can't get 63%, so let me change that to 62. With a sample of 50 voters at 62%, that would be 31 out of 50 voters voting for the winning candidate. That would be beyond a margin of error or beyond reasonable doubt that I have the winning candidate there. If I drop that down a little bit, I'm going to see that area start to increase. So the question is, if I had a sample where 56% of those 50 voters, or 50 times 0.56, 28 out of 50 voters, that's a lot closer to the middle of this distribution. So it could be an even 50-50 vote, and just by sampling error, I might get a disproportionately high number of votes for the winning candidate, and it's really highly likely that I'll land there. Definitely not more likely than not. It's about 20%, but something that happens 20% of the time happens 1 in 5 times, and that's a pretty considerable probability. So what we do with the hypothesis test is we decide what is our threshold. For homework problems, they're going to tell you, they're going to call it alpha. So alpha is a level of significance. We start talking about that all the way up here in the first section. It's also the probability of making a type 1 error. We don't really get into those specifically, but essentially a type 1 error is if we were to call an election too early and get it wrong. So we want to minimize that probability. Say for example, we're okay with calling that election wrong 5% of the time, then we'd want to make sure our sample has this right tail area of under 5%, under that level of significance. I believe that happened if my sample is 62% for the winning candidate in this distribution. So that's kind of the process in general. You can see it using Staplet, that version of it is pretty easy to see and visualize. We're actually going to do it a slightly different way. And we're also going to look at distributions where we're looking at the mean and standard deviation of quantitative variables. So we'll do both quantitative and qualitative hypothesis tests.